Okay, good day once again. Padayon ta sa atong discussion on methods of analysis, circuit analysis. So previously, we discussed about nodal analysis and we've seen how powerful it is and also very handy to use in solving circuit problems such as this. So in nodal analysis, we are concerned with finding the voltage at the node. Example, given this circuit diagram, we can get the node voltage of, let's say, kaning voltage 1, V1, V2, taking this one at node 0 as our reference node, and the non-reference nodes are 1 and 2. So basically, we are just trying to find the voltage at the nodes, and then everything will be, the rest will just follow. Nasolve mo ang current I1, I2, I3, and so on, depending on the circuit diagram. Now let's move on some mesh analysis. Okay, so mesh analysis provides another general procedure for analyzing circuits. And if mo gamit ang mesh analysis, currents na ang involved as variables. Unlike sa nodal nga ang ginapangita nato dito is voltage, but for the mesh analysis, we are looking for the current as our variables. So using mesh currents instead of element currents as circuit variables is convenient siya. So naman tayo ginatawag nga circuit currents or branch currents, katong real current yun, denoted as capital I. And for the mesh analysis, we'll be calculating first the mesh current denoted as a small I. Okay? Just to distinguish between mesh currents and the real current or the branch current. So nodal analysis kay ma-apply magamit og KCL to find the unknown voltages in a given circuit, while sa mesh analysis KVL ang ginagamit to find the unknown currents. Okay, so mesh analysis is not quite as general as the nodal analysis because ang kaning mesh analysis is only applicable to planar. Okay, so when you say planar, those circuit nga ano dapat wala siya crossing. Okay, so dili mag-cross ang imuhang mga branches. Okay, so wala na ang iyahang limitation. But other than that, it's quite powerful and useful and easy to use. So sa mesh analysis, natin terms ang ginagamit, we have the mesh current and we also have a mesh or the loop, a loop which does not contain any other loops o mura siya independent nga loop bitaw. Okay? So to understand mesh analysis, we should first explain what about mesh. So unsa man siya? So let's take a look at the circuit. Okay, so given this circuit, so if you take a look at the circuit diagram, we have two voltage sources, V1 and V2, and we have three branches or three resistors or resistances, and we have two nodes sa kanilang case. Okay, so for this example, we have path AB, EFA, so that's a closed path, so it's denoted by this small I1. This is what we call the mesh or the loop or the mesh niya nga current, the small I1. Okay, and also we have this loop, we have I2. So for this particular circuit diagram, we have two meshes. So muna siya ang ihang term. So meshes 1 and 2. Okay, but if you consider the path A, B, C, D, E, F, A, so kana siya nga closed loop, this is not considered as a mesh loop because it does contain two individual loops. So a mesh is defined as a loop which does not contain any other loop. So mo siya independent ng loop, or the simplest na loop. So the current through a mesh is called as the mesh current. So we have the mesh current 1 and 2. Mesh currents 1 and 2. Okay. So in mesh analysis, we are interested in applying KVL, or the Kirchhoff's voltage law, to find the mesh currents in a given circuit. So in this connection, we will apply mesh analysis to planar circuits that do not contain current sources. But later on, we'll consider that example na we have circuit diagram which contains current sources. Just like what we did sa nodal, as the simplest circuit, tapos nodal, another circuit na yun nga that contains voltage sources. Okay? But for the mesh analysis, muna na siya ang katong current sources. Okay? So sa nodal, we have voltage sources. Sa mesh analysis, we also have current sources ng mga types of circuit diagrams or problems. Okay, so to illustrate this one, we'll have a quick example on looking at a particular diagram, circuit diagram, and then try to find or apply mesh analysis. Okay, so let's take a look at this figure. Again, kanisha, let's consider this figure. Okay. So the first step is to require that the mesh currents I1 and I2 are assigned to meshes 1 and 2, which is what we did. Although a mesh current may be assigned to each mesh in an arbitrary direction, it is conventional na mo-assume ta ang mesh current kay flows in a clockwise direction. So, actually, pwede po siya counterclockwise, but for ano lang siya, ang iyahang consistency na, or simplicity na sake, pwede tayo consider nga kanilang sa counterclockwise siya na clockwise na direction. Okay? Then the second step, once you have this one established already, the second step is you apply the Kirchhoff's voltage law sa each mesh. Okay, so apply Kirchhoff's voltage law sa kanina mesh, and then for this mesh also. So applying KVL sa mesh 1, so consider mesh 1. If we apply KVL, okay, so let's take a look at, let's go along this direction. So we have positive V1, okay, patulong mo siya sa positive, and then the same direction sa current, so we have I1, R1, okay, and then pag abot nimo din kani siya, so duha naman ka mesh current we call this magtagbo, right? We have I1 and I2. So in that case, we have plus R3. So opposite it is positive. Then go with the flow sa current, we have minus I1. Okay? So that's our convention, right? And this is equal to 0. Okay, so simplifying this one, combining similar terms, we have R1 plus R3. So atong i-combine ang tanan variables at tanan constants nga under the same variable I1. Okay, I man ang ato ang or current ang ato ang concern sa mesh analysis. We have I1. Okay, so this is actually negative. Alright, negative. And then we have plus, okay, R3 I2, and then this is equal to negative V1. Okay, so imuhang i-change ang sign para positive na siya diha. So we have R1 plus R3 I1 minus R3 I2 equals V1. Okay, so we have this equation from our mesh 1. Now consider mesh 2. Okay, so for mesh 2, still magamit ang KVL. So we have R3, okay, and then we have I1 minus I2, right? Then we have minus R2 I2 minus V2 equals 0. And then again, combining similar terms, same variable siya nga I1. So we have R3 I1, right? And then we have minus R2 plus R3 I2, right? This is V2. Okay, so we have this equation. So we have two equations now, and we only have two unknowns, I1 and I2, so we only need two equations for this. So we can solve for I1 and I2 by using any methods na pwede magamit. Depende sa instructions kung gamit o by substitution pwede, or elimination method, Cramer's rule, and then using software such as MATLAB. Okay, so atong imuon siya nga matrix form ang kaning equation, kaning siya nga equation o kaning nga equation. So we have R1 plus R3, then we have negative R3. Sa ubos, we have R3 and negative R2 plus R3. Okay, this is our matrix. So we have, this is I1 and then I2. So sa right hand side, we have the constants V1 and V2. Okay, so we can easily solve this one using Cramer's rule or software, let's say MATLAB na software. And also from this diagram, take note also that so for this diagram, okay, if you look at the diagram, we know na ang capital I1, okay, is equal to the mesh I1. Okay, nasa dire, so in the same direction siya, so it is labeled as positive. If opposite ang direction sa I1, capital I1 o small I1, then that's negative. Okay, and the capital I2 is small I2. Okay, kana small siya. And then the capital I3, duha mo nakabuk nagsumpaki diha nga current, so that would be I1. Okay, in the same direction nun siya sa I3, in opposite direction siya sa I3, as big I3 we have I2. Okay, I1 minus I2. So kanilang siya, mas simplify po ng imuhang you can actually get the branch currents given na masolve mo ang mesh currents I1 and I2. Makuha naman I1, I2 kung small I1 and small I2 from this matrix. Okay, so let's have an example. So consider this example. Okay, take a look at this circuit diagram. So determine I1, I2, and I3 using mesh analysis, of course. Okay, using mesh analysis. So we already established the two meshes here. We have mesh 1 and mesh 2. So we will apply KVL sa mesh 1. So for mesh 1, yung equation would be, so we have 15, right? Then minus I1, so we have 5 ohms man na siya, so kanin siya nga mesh, and then plus 10 I2 minus I1, right, minus 10 volt equal to 0. Okay, so i-simplify niyo muna siya, you get this is 5 minus 5 I1 plus 10 I2 minus 10 I1 equals 0. Okay, so we have, ako na nang i-add, so you have negative 15 I1 plus 10 I2 equals negative 5. Divide the whole thing by negative 5, so we have 3 I1 minus 2 I2 equals 1. Okay, so we have 3 I1 minus 2 I2 equals 1. So muna ito ang equation for mesh 1. How about for mesh 2? Okay, so the same process applies. Start with this resistor 6 ohm, so we have negative 6 I1 minus 4, this is I2, 4 I2 plus 10. Okay, 10 volt na siya. Then ang katong 10 ohm, nagsumpaki mo na siya nga current, so we have I1 minus I2 equals 0. Okay, so simplifying this, so we have 6 minus 4 I2, we have negative 10 I2 plus negative 10 I2, so we have negative 20 I2, so 10 I1 minus 20 I2, okay, this is equal to negative 20. So divide the whole thing by 10, I1 minus 2 I2 equals negative 2. Okay, sakto ba? Sorry, nasayap ko. This is only negative 10. Alright, and then this is negative 1. Or I1 is just 2 I2 minus 1. Okay, so natay duha ka equation, and since the second equation is already expressed in terms of I2, so ato na siya i-substitute din ha. So substitute it here, you should be able to get the values for I1 and I2. So if you do that, masolve ni mo nga I1, if you do that, ito siya imo na siya i-substitute. It's easy to see nga by substitution, I1 is just 1 amp, and then ang I2 is 1 amp also. Okay, so having known this one, automatic na siya na from here I1 is just I1 is just I1 na ang capital I2 is I2, and then the capital I3 is just I1 minus I2. Right? So muna isabot diha, ang capital I1 is just 1 ampere. This is 1 ampere, and then capital I3 is 0 amp. So technically, wala mo agi diha nga current dito sa I3. Okay, it's just 0. So simple substitution will do its magic, ma-solve nimo siya. But let's try to solve it using Cramer's rule. Okay, gamit man yung Cramer's rule if nakay tulo na ka unknowns. Okay, so let's try to solve using Cramer's rule para iabot nimo sa 3 to 4 higher dimensions, higher na mga sets of linear equations. Magamit nimo ang Cramer's rule kay masayon siya isolve. So let's write this first in matrix form. Kani in matrix form na siya kaning equation kaning duha. So in matrix form we write 3, negative 2, and then we have 1, negative 2. Right? This is I1, I2, we have 1 and then negative 1. Okay? So pwede na siya magamit kag MATLAB software, but let's try to use Cramer's rule this time para let's try to confirm mapareha dapat siya og result. So for Cramer's rule, yan is here. I1 is just delta 1 over delta. So determinant na siya. I2 would be, or ang simplify siya. In general, I sub j delta sub j over delta. Okay, where j runs from 1 to 1 up to 2 na siya, kay duha naman siya ka subscript. Okay, if tulo na siya, so 3 pud na. Okay, so let's try to solve first delta 1. Okay, so this is determinant delta 1. So ang wato ni mo ana para makuha ni mo ang delta 1 is this. Imo na siyang i-cover. Okay, then pulihan ni mo ani nga values. So we have 1, negative 1, and you copy the right hand side. Okay. Let's use the black color. Okay, we have 1, negative 1, negative 2, negative 2, and you get the determinant. Okay, pagkuha sa determinant is yung cross multiply naman na siya. So this is multiply. So we have negative 2 minus ang product ana. Okay, negative 1 times negative 2 is positive 2. So we have 2. So this is negative 4. Next is your delta 2. So kuan gihapon for delta 2, kabira nimo is kanin siya, pulihan nimo ani nga values. Okay? You get this. Okay. Three, 1, then 1, -1. Okay? If you do the determinant, imong multiply katong cross multiply siya kaning the same nga process. So we have -3 minus 1. Okay? So this is -4. Then lastly, determine mo ang determinant sa kaning nga matrix. Itong original nga matrix. Kani siya. So we have 3, 1, -2, -2. Okay, that matrix. If you do that, we have -6 plus 2. Okay, so we have -4. So we can now solve for I1. So that is I1, delta 1 over delta. Okay, so we have -4 divided by -4, that's 1. And then for I2, have delta 2 over delta. So -4 over 4, that's 1. So the same as akong mga process, the same result, right? Lahat lang siya nga method. Okay, so that's it for the Cramer's rule. Then we'll have another example. Okay, let's take a look at this example. So consider this circuit diagram. So use mesh analysis to find I0 in the circuit. Okay, so we have 3 meshes here, I1, I2, and I3. So we'll apply KVL for each mesh. Okay, so consider mesh 1. Okay, so for mesh 1 we have, using KVL, 24 plus I2 minus I1, right, plus 12. Okay, so we have I3 minus I1, I3 minus I1. Okay, this is equal to 0. So simplifying this one, combining all similar terms, you get 11 I1 minus 5 I2 minus 6 I3 equals 12. Okay, so kanay umakuha. This is for mesh 1. For mesh 2, okay, so we have 10 I1 minus I2 minus 24 I2 plus 4 I3 minus I2. Okay, so this is equal to 0. So simplifying this one, we should be able to get say negative 5 I1, i-check lang ninyo na siya, plus 19, this is just algebra, minus 2 I3 equals 0. So this is your second equation from mesh 2. So for mesh 3, should be able to get start with the negative 4i na plus 12 I1 minus I2 or I1 minus I3 I mean, okay, plus 4 I2 minus I3 equals 0. But we know nga at node A, where's node A? Tara. So we know that at node A, I naught is equal to I1 minus I2. Okay? From, ano na siya? KCL na siya. Okay? So we can simplify this equation into just this one. Negative I1 minus I2 plus 2I3 equals 0. Okay, so we have three equations now. So mugamit na rin tayo katong Cramer's rule. So pwede ang Cramer's rule ani if we will solve it by hand. So let's establish first the matrix. So we have 11, negative 5, negative 6, right? Then we have the second one is negative 5, we have 19, negative 2. The third equation is negative 1, negative 1, we have positive 2. Okay, so we have this one. And then we have the column vector I1, I2, I3 equals this column vector. We have 12, 0, 0. Okay, so we can solve this one using using Cramer's rule. Ano naman, diba? So we have I sub j is equal to delta sub j over delta. Okay, so let's solve first. Let's calculate first the delta atong overall. Okay, so if we want to find the determinant of a 3 by 3 matrix, can you see a 3 by 3 matrix? All you have to do is use the basket method. Okay, so you copy this. Kani ito yung kopyaon. Copy this one. Na. Okay, and then after that, imo na siyang i-extend. Copy the first two rows kanin siya sa ubos para mag-kuhan siya like 11, negative 5, negative 6, negative 5, 19, negative 2. I-copy lang nimo ang first two row so that naakaani. Okay, the next thing to do is imo siyang i-multiply katong basket method gihapon. So it's actually this, multiply din mo siya, multiply that one, that's positive sign, multiply this, positive sign, and multiply that one, positive sign, and then ang opposite niya is this is negative sign. Okay, I hope you are following. This is negative sign, and then this one negative. Okay, so if you do that, so i-multiply na mo siya. So you have negative 1 times negative 5 times negative 2 plus ano na siya. So itong i-calculate. Let me get my calculator first. Okay. So we have negative 1 times 5 times 2. So we have negative 10 plus 5 times 1 times 6. Okay, so negative 30 na siya. Negative 30. And the last one is 11 times 19 times 2. Okay, so we have 418 plus 418. And then minus, ang kating opposite sign, pwede na to siya i-close, tapos the rest kay, ano siya, minus na siya nga sign din ha, then plus na kanan din ha. Okay, so we have 114 plus 22 plus 50. Okay, multiply na siya. Okay. Or pwede magsubo din ha. We have 114, so we have 22, then we have 50. Okay? So we get 192. Mo siyang i-calculate diha. Okay? Next is you get delta 1. Okay? So for delta 1, kato naman ang kuan, for delta 1 i-cover nimo siya. I-cover ni siya nga column, pulihan nimo ani. So we have 12 0 0. Then you copy the rest, negative 5, 19, negative 1, negative 6, negative 2, then 2. Since we are trying to find the determinant sa 3x3 nga matrix, for this case, the same method atong paggamit ani. You copy the first two row, basket method mo siya. And we have 0, 19, and then negative 2. Okay? Muna siyang i-kuan din ha. You get the determinant. So you'll be the one to check it na lang. Basta akong ibuta ang answer, it's actually 432. Okay? And then for delta 2, okay? So for delta 2, ang kabira nimo is ang kanina pod siya, ang kaning second, pulihan nimo ani nga values. So you get this one, 11, negative 5, negative 1, 12, 0, 0, negative 6, negative 2, and then 2. If you copy the first two row, 11, 12, negative 6, negative 5, 0, and negative 2. Okay, if you get the determinant of this, the same gyapon nga process ha katong mag-multiply ka ana. So we have ana multiply, here we multiply, so multiply, multiply, multiply. Okay, wala ko siya katarod click. Kana siya ang i-multiply. This is minus sign, plus, plus, plus. It's okay. You should be able to get this value, 144. And then for delta 3, ang kabira nimo is kanina po, pulihan nga value. So you get 11, negative 5, this is 12, 0, 0, kana ulit mong gipulihan. So negative 5, 19, negative 1, negative 1. You copy the first two row, 11, negative 5, 12, then we have negative 5, 19, 0. Get the determinant, you should be able to get this value, 288. Okay, so we've already set up the following. So we should be able we'll be able to determine I1, which is just delta 1 over delta. This is 432 divided by 192. So this is 2.25 ampere. For I2, we have delta 2 over delta. So this is 144 over 192. You get 0.75 amp. Okay. And then for I3, we have delta 3 over delta. This is 288 over 192. This is 1.5 amp. Okay, we'll determine I1, I2, and I3. Then we go back to our question, which is, what is I0? Find I0. We know na ang I0 is given by this. Mamani ang I0, diba? So, ato na siyang i-substitute diha. Let's go back here. So, I0 is just 2.25 amp minus 0.75. So I0 will be 1.5 ampere. So muna na-determine na nimo ang current. Okay? Next is we'll consider circuit diagram wherein na ay current sources. Okay. Okay, let's consider. So we have mesh analysis with current sources. So consider this circuit. Okay, so we have this circuit. So for this particular case, ang imuhang current source is na exist sa isa lang ka mesh. Okay? So naa siya din. We will set na ang I2 is negative 5 amp. Okay? Kaya opposite mo siya nga direction. So it's negative 5 amp. And then we will write the mesh equation the usual way na dayon. Okay? So let's consider mesh 1. So for mesh 1, we get 10 volt minus 4 I1 plus 6 I2 minus I1 equals 0. But since I2 is negative 5, we get 10 minus 4 I1 plus 6. So negative 5 minus I1 equals 0. 10 minus 4 I1 minus 30 minus 6 I1 equals 0. Right? So this is negative 10 I1 is equal to positive 20, right? So I1 would be negative 2 ampere. So dali na siya ma-solve. Ano lang. So muna siya mahitabo if we have current sources sa imong circuit diagram. So we just have to set whatever ang mesh current na naadin ha. Tapos depending on the direction, if opposite siya, it's negative. If it's along the direction sa imong mesh na loop, then it's positive. Okay? The next case is, what if ang kanisang current source is nasa tunga? Okay? Let's take a look at this circuit to illustrate this point. Okay, so take note, nasa tunga ang imuhang mesh, ay imuhang current source. So in that case, i-exclude din mo siya nga element to get this new circuit. Okay? Sa nodal analysis, we have super node, di ba? Kaya mausa naman nimo ang 2 or 3 nodes. For this case, ang duha ka mesh, mausa po siya. We call this a super mesh. Okay? So, we have super mesh. Nausa nimo siya, isa ka loop. So, I1. But it still contains the two mesh currents, I1 and I2. Okay? So, ang kaning super mesh, mo apply gihapon ang KVL. It's like any other mesh. So, if we apply KVL, we get positive 20 minus 6 I1 minus 10 I2. Okay, agi sa diri I2 na siya. Minus 4 I2. That is equal to 0. Okay? Or simplify din mo na siya, you should get 6 I1 plus 14 I2 equals 20. Okay? Since duha imong unknown, dapat duha imong equation. Okay? So we will get the another equation from this junction. Okay? Apply tag KCL diha sa junction ni 0. So sa junction 0, we have I2 is equal to I1 plus 6. Okay? So direct substitution naman ni siya. Imo na siya substitute diha, should be able to get I1 is negative 3.2 amp, and then ang I2 is 2.8 amp. Okay. So once magkuha na nimo ang I1 and I2, makuha naman nimo dilute so ang unsa ang current amo agi diha and so on. Okay? So note the following properties sa imuhang super mesh. So sa super mesh, the current source niya is it provides the constraint equations necessary to solve for the mesh currents. Ang super mesh also has no current of its own, and the super mesh requires the application of both the KVL and the KCL. Okay? So another example, if you take a look at this, okay, this circuit, kana. So take note, natay duha ka current source. Okay? So natay super mesh din hidapita, kaning nga division and kaning nga division. But since pwede naman siya mausag siya as one big super mesh. Okay? So we have it encompasses this kind siya nga boundary. Okay? So we have one super mesh here. So we can actually find what is I1. So makuha nimo ang I1 and makuha pa nimo ang I4. So kana ang I1 and I4. Even I2 makuha nimo. Okay. Also I3. Masolve mo siya, and also I0. Okay? So for this particular case, magamit ta og KVL sa kaning super mesh. Okay? And then magamit ta og KCL sa node P. Okay? And also KCL sa node Q. Yan na. And another KVL sa mesh 4. Okay? So if we apply KVL sa kaning super mesh, okay, so we get negative 2 I1, right, minus 4 I3 plus 8 I4 minus I3 So nag-ana ta dagan ta dinha pa ana dinhi minus 6i2 equals 0. Okay? If you simplify mo na siya, you should be able to get i1 plus 3i2 plus 6i3 minus 4i4 equals 0. Okay? So let's label this as equation 1. Okay? Next is mag-apply ta og KCL sa point P. So at node, this is at super mesh. And at node P, apply KCL, natin I2 equals I1 plus 5. Okay? So this is equation 2. And then at node Q, natin I2 equals I3 plus 3 I0. Okay, so this is equation 3. But we know nga ang I0 is negative I4. Tanawan mo din he. Take a look at I4, it's opposite sa I0, so that's negative I0, or I0 is negative I4. Okay, nanataani. So masimplify mo ang I2. So instead of I0, so this is minus 3I4. Minus 3I4. Okay, tungod ani nga equation. Next is apply KVL at mesh 4. Okay, take a look at mesh 4. So we have negative I. Ito na siyang para dito nga dito sa taas. Okay, so at mesh 4, take a look at this mesh. We get 8 I3 minus I4, right, minus 2 I4 minus 10 equals 0. Okay, so simplify na muna siya. You should be able to get negative 4 I3 plus 5 I4 equals negative 5. Okay, so we have, this is equation 4. So we need 4 equations because upat man ka unknowns. We have I1, I2, I3, and I4. So the same process gihapon na pag-solve ani is either we'll be using substitution elimination method or Cramer's rule or MATLAB. Okay? So for that case, mo siya establish ang imuhang matrix. So you have 1, 3, 6, negative 4. Okay? So we have 1, okay, negative 1, 1, 0, and 5. So kani equation 2. So for equation 3, we get 0, we have 1, negative 1, positive 4. Okay? Sa equation 2 is, ano siya? Balik sa equation 2. So sa equation 2, we have, mo siya balhin niya, negative 1, positive 1, and then wala kay 3 and 4, so 0 na siya. Okay. For the equation 4, wala kay I1, wala kay I2, but na kay I3 and I4. So this is negative 4 and then positive 5. Okay? Ano siya? I1, I2, I3, I4. And then the column vector sa right hand side of the equation should be 0, 5, 0, and negative 5. So you can actually solve this one using MATLAB. Try this sa inyong kagaling na computer. During your free time, you should be able to get I1 is negative 7.5 amp, I2 is negative 2.5 amp, I3 is 3.93 amp, I4 is 2.143 amp. You should be able to get this one. Sa'yo naman na siya, yung mga input ni siya nga values sa MATLAB. So that's it. Given I1, I2, and I3, and I4, you should be able to get the following. I0, this one, the capital I0, na-solve naman nyo siya. Where capital I0 is just negative I4. Ito na. Okay, that's easy to see. Okay, so that's it for for the methods of analysis. We discussed nodal, and then for this particular session we discussed the mesh analysis. Okay, so that would be all for now, and see you on the future or next videos na itong ma-discuss electronics. Thank you.